Hi, my name is Damon Rocha. For my project for Web3Hacks, I built out the app CipherView AR, an AR application that allows users to view wallet data for a Hedera hardware wallet that is created using Arduino, Node.js, React, and TensorFlow.js. Let's check out a demo. This application will allow users to lift up their device, put it up to the camera. The backend application, or the React application, will call Hedera and return the balance and the account ID. While it's not super accurate yet, this is very extensible and can be extended to showing a lot more information, and with a better model that's trained just for this could pick it up a lot easier. As you can see at the top there's the balance of 0th and the address of 0x29. Cover how this application works. As stated in the beginning of the video, one of the main drivers of this application is the hardware wallet itself, which for our use case of just a few days, it was just this Arduino program that holds this test address. That's not mine, it's just a known test Hedera address. It has this loop that's consistently running as long as Arduino's on, where it is waiting for this get Hedera address in the serial port it's on. As soon as it finds that, it gets the serial address, or gets the Hedera address and writes that back to the serial port. Now this gets read in this Node.js file, which is using the serial port, and it's looking for COM12, which just so happens to be the communication channel of the Arduino. It will, on call of this function, send this data to the serial address, which is the same as that. Then any data it gets back, it adds to a buffer and resolves that. And so if you call this get endpoint, it will go through that get address and then clear the buffer once the data is saved here, and then send it over to the front end. And for the front end application, this is where a lot of the magic happens. So it's using TensorFlow, CocoaSD for object detection, webcam to show the webcam, and then a drawRect utility function that I created. Along with that, it's using Hashgraph SDK to talk to the Hedera, and Axios to call the backend. So I'm going to skip through a lot of the setup stuff, but from here it's just running the CocoaSSD for object detection and then detecting objects every 10 seconds. In this, we go through into some more setup of detect any objects, get our context, and then pass it into our drawRect. And in this drawRect function, we will check the classification of the object, and based off of that, then we'll draw a square around it and pass in this info, which is what we'll cover next, and that is the account and balance. So if the address is set, which is done here after calling this get Hedera address for the node endpoint, then we'll go through and get the cached account and cached balance. We'll cache those, set them, and then we return them here. So that is then sent over to drawRect, which draws a rectangle around the object, and then, like you saw in the demo earlier, writes out the balance and the address info. And that's about it. The only thing underneath it is the use effect and the JSX to actually show everything. And that's my application. I feel like this could really help secure hardware wallets more. It's hard to pull this into like a widespread use case though, for the simple fact that you have to connect this locally. So eventually in the future, it would be awesome to extend this where you could like have RFID and a Wi-Fi based Arduino or microcontroller that could control access and authorization to and from the hardware wallet. Well, thank you very much.